So hello guys, we were discussing graphs. So we had discussed some basics. Now let's move to some advanced things, guys. So as we were discussing graphs, so let's move to some more concepts in the graphs. Okay, let me start with now with some good things. Just give me a second. Okay. So say for example, I throw a ball here with a speed of 20 meter per second. Okay, motion under gravity. So now we can plot graphs in terms of data as well. So I need to draw three graphs in this case: x versus t, second is velocity versus time, and third is a versus t. Okay, so now can you see what is the time of flight? When the velocity, when it reaches the highest point, what would its velocity, what would be its velocity? 0. And what would be the time? 2 seconds. Can you see that the time of flight would be 4 seconds? I gave you the formula, and in fact you can think like that. 20 meter per second is the speed, and 20 meter per second is the speed, and it's getting less with the it is getting reduced with the rate of 10 meter per second square. So 2 second up, 2 second down. Okay, so let's we'll draw the graph. First of all, in this case, acceleration is constant or not? So acceleration is constant. Okay, so the same thing we had discussed. If the acceleration is constant, velocity versus time would be a straight line, and x versus t would be a parabola. Now which parabola? This parabola or this parabola? It depends on whether acceleration is positive or negative. So acceleration is always negative in this case, because it negative means the direction, if upwards or it's downwards. So it is downwards, so I'm going to take it this one would be the case. Okay, so let's draw. Excuse me. Okay, see the solution. First I'm drawing x and t graph. Just give me a second. So solution, and I'm drawing x t graph. Okay, and what is it actually? Say, can you see that it reached its highest point at t equal to 2 seconds? Okay, then I know that it has to be parabola, and this parabola, downwards parabola. So it would reach its highest point at t equal to 2, and then it's come back, and displacement ultimately would become 0. So that means displacement is getting 0 with time. That means it's come back to its original position. So this is 2 seconds, and this is 4 seconds. Okay, in seconds. So this is x versus t graph. If I need to draw, v versus t, so let me draw in the other page. Let's draw v versus t. Okay, v versus t. So if I represent velocity in the y-axis and of course time in the x-axis, so velocity is going to constant. Okay, not constant. Velocity is going to be velocity versus time would going to be a straight line. And the thing is, velocity was 20 in the beginning, and is going to decrease. It has to be a straight line because acceleration is constant, and then again decrease. Not decrease means in the negative direction. This time is 2 seconds, and when it reached at the bottom, when it reaches the point of throwing, it would be 4 seconds, as we had discussed, 4 seconds. So this is the velocity versus time. Now the third was acceleration versus time. So acceleration versus time, can you see the acceleration is constant because in this motion under gravity acceleration is always constant, and that is negative 9.8 or negative 10. So this would be just a straight line if acceleration versus time I ask you. Okay, so let's discuss another problem. I hope that is clear to you. Okay, I'll give you another problem. In this case, what I'm doing, say for example, I throw a ball with a velocity of 10 meter per second vertically upwards. Okay, and say for example the height is 15 meter of this tower. Okay, and now again need to draw three graphs: x versus t, velocity versus t, and c is acceleration versus t. So I need to draw these three graphs. Okay, so let's come to the point. Say for in this case, this has to be a parabola, this has to be a straight line, and this has to be again a constant. Okay, parabola, and the parabola would be the same type, downwards. It has to it has to open downwards. Now the thing is, what we take as origin, the point where we are shooting the particle. Okay, the point of throwing the particle is taken as the origin or reference. Okay, and can you tell me the time of the flight in this case? 1 second, because it would be 1 second upward and 1 second downward, so that would be 2 seconds. Coming to the top of the tower, this is the time from the tower to the again coming to the tower. This is 2 seconds. 1 second it is taking to at the maximum height, because the height velocity is decreasing at a rate of 10 meter per second square, and velocity was 10, so it would be 10 10 1 second. In 1 second it would be upwards, and in 1 second it is coming back. Okay, so 2 seconds was the time of the flight, but it is also going downwards and crossing this 50 meter. Okay, so the motion is actually this way. It goes there and there. So you can find the total time. In the total time of the flight, you have to take displacement as minus 15. Okay, minus 15, because this is the displacement. Net displacement is this. If you solve that, it would become as like 3 seconds. Okay, solve it yourself. Now I'll draw the graph. Just look at the graph of different cases here. First of all, let's draw x over t. Okay, x over t, x versus t will draw. Okay, so the thing is, first of all, the displacement is increasing, and in 1 second it is reaching the top point, and then 2 seconds is coming to the same point, and then again it is decreasing. So x versus t would be this. So this would be 1 second. And if I talk of the second one, velocity versus time, so you can think like that it would be a straight line as the acceleration is constant. So velocity is decreasing. It starts with a 10, and then it is decreasing, and then getting 0, and then this. So this would be 1 second, t equal to 1 second, and it is 10 meter per second, and is decreasing. Okay, then if I need to ask you the third one, acceleration versus time, which is the easiest one, even I think I did not know to I think that I did not need to draw it, but the thing is very easy. It has to be constant, motion under gravity, and it is like minus 10. Okay, this will be minus 10. So most of these are the basic, and we had discussed it. Now if I need to refresh some things of yours, or just demonstrate you something. If I say x versus time graph, this is one x versus time graph, and this is like a straight line, then what does it represent? Body at rest. There is no displacement. It is getting constant with the time now. The value is constant with the time, so body it is at rest. Okay, if I say draw the VT curve of that, so what would you do? Nothing, because body is at rest, no velocity. And draw the acceleration AT curve, you would say nothing, because the body at rest, no acceleration, no velocity. Okay, and if I ask you this thing, say for example, if I draw this VT curve is like this, so what would you say? Velocity is constant. Here velocity is constant, not zero. Okay, so the body is moving, with constant velocity. Okay, so this is the you can say that this is the conclusion from that. Okay, body is moving with a constant velocity, and what is the acceleration? Acceleration is zero. But if I say what is the displacement, so displacement curve, displacement versus time would be a, yes, exactly, it would be a straight line, because the velocity is constant. So if I say what is the x versus t graph in this case, because the velocity is constant, so I can say that like this. Okay, this is one. I don't know the point of origin. I just take it like as the origin itself. Okay, origin is taking at the origin. The point of starting I took as origin itself. And what is the acceleration versus time graph of that? Nothing. Okay, acceleration is zero. Acceleration is equal to zero in this case. Acceleration equivalent to zero. I just need to increase its brightness. Okay, clear? Very good, very good. Okay, then I'll ask you one more thing. Okay, don't worry. And that one more thing is this. Say for example, I give you like x versus t graph like this. X versus t graph like this. Okay, this one. So what if I ask you what is the v versus t graph of that? V versus t graph of that. So you can say that it is like it is going with the x-axis and then raising upward. So velocity is like zero initially, and then it is increasing. Okay, and it is increasing, but it would be a straight line. It would be a curve. It would be a straight line. Why? Because whenever the graph of x versus t is a parabola, the graph of v versus t would be a straight line, and it is the case of constant acceleration. This is a parabola opening up upwards, so v versus t would be a straight line, and a versus t would be a line parallel to x-axis. Acceleration would be constant in this case, and even positive. If I ask you what is the acceleration versus time graph of this, first of all it would be constant, and it would be positive even, because it is opening upwards. So a versus t would be like this. I don't know the value of this, but the thing is it would look like this only. Okay, because it is opening upwards. This parabola is opening upwards as the velocity is increasing. Okay, if x versus t would be like this, so velocity is decreasing. Okay, the acceleration would be negative in that case. I hope you are getting my point. So I just need to show you something. So the thing was this. Okay, let's discuss it in the next video.